solving Math Applications SL, Paper 2, May 21, Time Zone 1. Let's get started. Question number 4. The stopping distances for bicycles traveling at 20 km per hour are assumed to follow a normal distribution with mean 6.76 meters and standard deviation 0.12 meters. Under this assumption, find, correct to 4 decimal places, the probability that a bicycle chosen at random traveling at 20 km per hour manages to stop in less than 6.5 meters. So here we are talking about a normal distribution, and we have the mean, we have standard deviation, and we need to calculate the probability. Here we need to calculate the probability. So in order to solve this question, again we will use, as usual, our graphing display calculator. But here it's very important to sketch which probability that we willing to find. How? So for I, we are talking about this normal distribution curve, the bell-shaped curve. We know that the mean is in the middle. This is 6.76. This is our mean, and the standard deviation, this is the steps that we are adding or subtracting 0.12. We need to find the probability that the bicycle will manage to stop in less than 6.5 meters. So 6.5 is less than here, so 6.5 is less than 6.7, so we may assume it's here. And we need to find the probability that the bicycle is here, less than 6.5. So this shaded area, this represents the probability that we need to find. So we will use our calculator to find this probability. So to find this probability in both Casio or Texas calculators, we need to press distribution in our calculator. You will find this distribution when you enter in the Casio calculator menu, press menu, then go to stat, then you will find distribution, DIST. So, or in the Texas calculator, you have a separate button for this distribution. When you press, you will find many options. What we need is normal CD. Normal CD. This is what we are using here. So this is normal distribution. We will, when we enter normal distribution, we will, in the screen of the calculator, we will receive some items we need to fill. First, it will ask about lower. What is the lower? This is the smallest value here in this shaded area. This shaded area will continue in this direction, which is negative infinity. How we will insert in the calculator that the lower is negative infinity? We insert negative, and then we will press 99999, as much nines as you can write. So this will represent the negative infinity. This is the lower boundary. Upper, so in this shaded area, the upper is 6.5. So this is low, this is upper. Lower boundary, upper boundary. Upper will be 6.5. And also it will ask about standard deviation, 0.12. It will ask about the mean, 6.76. you will press enter, execute, calculate. We will get probability that x less than 6.5 will be 0.0151. And here I wrote my answer into 4 decimal places as it's requested. Double I. We need the probability that it will stop in more than 7 meters. So we will repeat more than 7 meters. Here is the bell shape. This is the mu, 6.76. 7 meters is here. We need more than. So this. So what would be the difference? So the difference here will be lower is 7. This is the minimum. And the upper is here. The end of this shaded area is the positive infinity. So positive infinity is 9999999. As much nines as you can write. So you will, and also you will insert the standard deviation 0.12 and the mean is 6.76. Calculate, execute. So probability x is more than 7 will be 0.0228. This is the probability. Then 1,000 randomly selected bicycles are tested and their stopping distances when traveling at 20 km/h are measured. B. Find correct to 4 significant figures. Now 4 significant figures. The expected number of bicycles tested that stop between 6.5 meter and 6.75 meters. So it's the same thing, but here we have lower 6.5. We will insert lower 6.5 and upper is 6.75. And once you will do this, you will find the probability that x between 6.5 and 6.75. The probability will be 0.4517. But here it is not asking about the probability, it's asking about the expected number out of 1,000 bicycles. So to find the expected number, all what we need is the probability times the total, which is 1,000, and this will equal 451.7. 451.7, this is our 4 significant figures. So we are calculating the probability, multiply by 1,000, we will get the expected. The same for double I, probability x is between 6.75 and 7. We will get 0.5105 times 1,000, so 510.5. So this is the expected number of bicycles between 6.5 and 6.75. This is the expected number of bicycles between 6.75 and 7. Then the measured stopping distances of 1,000 bicycles are given in the table. So less than 6.5 meters, number of bicycles are 12 out of this 1,000 bicycles. This is the observed data. This is when we checked these 1000 bicycles, this is what we saw. Between 6.5 and 675, it's 428. What we was expecting here, we can notice that what we expected 451.7, in reality it was 428. And stopping distance 6.75 and 7, this is 527, and more than 7, this is 33. It is decided to perform a chi-square goodness of fit test at 5% level of significance to decide whether the stopping distance of bicycles traveling at 20 km per hour can be modeled by a normal distribution with this mean and standard deviation. So now we are dealing with chi-square goodness of fit. State the null and alternative hypothesis. So the null hypothesis, what we need to test is we need to check if the stopping distance can be modeled by this normal distribution or not. So this is our null hypothesis, that stopping distances can be modeled by normal distribution mu 6.76 and 0.12 squared. This is how we are writing the normal distribution. So this is the null hypothesis. What would be the alternative? Alternative hypothesis, this is the same but cannot be modeled. The same cannot be modeled by this normal distribution. Find the p-value of the test. So now we need to insert this information to the calculator and calculate chi-square GOF. Here, in order to perform this, all what we have now is the observed values. So this, we will insert the observed values into L1, we'll insert stats, we'll go into stats in our calculator, and in L1 we'll insert these 4 values. This is our L1. Then in L2 we need to insert the expected values. We already know, we already calculated the expected between 6.5 and 6.75. This was 451.7. This is we calculated here. And between 6.75 and 7, we already calculate the expected number of bicycles. It was 510.5. Now we will do the same for less than 6.5. We will find the probability, then multiply it by 1000. And here you must notice that the probability less than 6.5, we already calculated it. So this number multiplied by 1000, we will get 15.1. And the probability that more than 7, it is here, 0.0228. This times 1000, we will get 22.8. So we're multiplying this by 1000, this by 1000, to get the expected values. So we have L1 and we have L2. We'll insert these two columns into stats. Then stats, tests, chi-square GOF. It will ask about the observed is L1, expected L2, then calculate. We will find that p-value is 0.0727. This is our p-value from the calculator. E. State the conclusion of the test. Give a reason. So, if the p-value is 0.0727 and level of significance is 5%, so we can see that the p-value, this 0.0727, is more than alpha, the level of significance, which is 0.05. So when p-value is more than alpha, we accept the null hypothesis. What is the null hypothesis? That the stopping distance can be modeled by this normal distribution. So there is evidence. There is evidence here that stopping distances can be modeled by the normal distribution. So this is the reason here that the p-value is more than alpha, and this is our conclusion. This was our fourth question in this paper. Thank you, and I'm waiting for all your questions in my social media accounts. The links in the description box. See you next video. Goodbye.